All right, what's up, guys? Let's get to business right here. We're studying for this momentum test tomorrow. So, question one. What's the speed of a 1.0 times 10 to the third kilogram car that has a momentum of 2 times 10 to the fourth kilogram meters per second to the east? So you know that momentum equals mass times velocity. They want to know the speed, so they're looking for this. They've given us the momentum, which is 2 times 10 to the fourth. They've given us a mass, which is 1 times 10 to the third. Solve for V. Divide each side by this. And you should get the answer to be 2, which is 2 times 10 to the 1. Question 2. The magnitude of the momentum of an object is 64 kilogram meters per second. If the velocity of the object is doubled, the magnitude of the momentum of the object will, so in this case, P equals mv. If the momentum is 64, right, and let's say you doubled the velocity, then what's going to happen to this is also going to get doubled. So if you double the velocity, you'll have doubled the momentum. So it should be 328. Question 3. What's the momentum of a 1,200 kilogram car traveling at 15 meters per second due east? So same thing, you're looking for momentum. You have the mass of the car, 1,200. And you have the velocity of the car, 15. So 1,200 times 15 is going to be 1.8 times 10 to the fourth. And now in this case, direction matters, so this is east. Question 4, what's the momentum of a 1.5 times 10 to the third kilogram car as it travels 30 meters per second due east for 60 seconds? So here they're giving you time, they're giving you 60 seconds, but you don't use that in the momentum formula, so it's just kind of like extra information you don't actually need. So once again, the mass of the car, and it's traveling at a speed of 30 meters per second. So you multiply those out, and you're going to get 4.5 times 10 to the fourth, and this is also east. Let's see. 5. What is the unit of momentum? So we've already seen this a couple times. They even tell you in the questions beforehand, momentum is measured in kilograms times meters per second. 6. In the diagram below, a 10 kilogram ball is fired with a velocity of 500 meters per second from a 1,000 kilogram cannon. What's the recoil velocity? So pretty much you're finding out what is the velocity. Let's draw a little cannon here. We got a little cannon here. It fired out a cannonball. You have a velocity in this direction, and the cannon is going to have a velocity in that direction after it gets fired. So this is conservation of momentum. All right. The momentum at the start is equal to the momentum at the finish. So you have to look. What is the momentum before the collision happens? Well, before the collision, the cannon has 0 momentum because it's not moving. And the cannonball also has 0 momentum because it's not moving. Then you have the collision. All right. After the collision, we have that the cannonball, which has a mass of 10 and a speed of 500, and that's moving to the right. So if we say this is moving to the right, we could say that this is positive, so this is the positive direction. And we're going to add to that the momentum of the cannon. Now the cannon has a mass of 1,000, and we don't know what the speed of the cannon is at the end. So that's what we're looking for. So the momentum before the collision was 0. So we know that the momentum after the collision has to be 0. So in this case, we can say that 0 equals 5,000 plus 1,000 VF. Subtract 5,000 on both sides. And then we're going to get negative 5,000 equals 1,000 VF. Divide each side by 1,000. And we get that the velocity of the cannon is going to be negative 5. But now this negative really means that it's to the left, because we said that the cannonball was moving to the right, and that was the positive. So this could also be considered as 5 to the left. So since they're just looking for the velocity, this is going to be choice 1.